what's going on. All right, part 2 of this video, just to refresh our memories of where we got up to. We've only put in mode number 2 for now, which is where you type in your target frequency and it gives you, well, it should give you the LPF value in Wwise and the HPF value. We've only implemented the LPF, but it's printed out that value and presumably it's correct. So 37 is 3829. We typed in 4000. Yes, and that is the closest. I mean, it's right in the middle of 36 and 37. But yeah, I assume it's a little bit closer. My quick maths is lacking. All right, let's let's move on to the LPF table. So yeah, this is going to be very, very similar. We could almost copy and paste the whole lot, I feel like. You know what? I think we can copy and paste the whole lot. Oh, but before we do that, we need to declare 2 new variables. So closest HPF frequency. Start off with a crazy big number. And then closest HPF Wwise value starts off as 0. Okay, and then, yeah, I think we can just copy and paste this stuff. Being very careful to change the variable names. So this is local, so that's a new thing. We want this one here. Frequency search is the same. It's the same thing that we put in. So anywhere where there was closest frequency, we now need to change that, and same with Wwise value. And we don't need those notes. Apart from that, that's the same. Now I might rename these because this says HPF, this doesn't say anything. So that can be LPF. So now I'm gonna make sure everywhere where there was closest frequency referenced. Yep. And this one, closest LPF Wwise value, which is there and there. All right. Now, I'm going to get rid of one of those character returns. Remember, the /n is a character return. So I only want a new line now. So we can add to this message by going message is message concatenated with more strings. Yeah, so we're so the HPF value that is closest to that will be closest HPF Wwise value. And now we'll do our double character returns again. Now I might have got something wrong. We did quite a bit of stuff just then, but let's have a go. Cool. So looking for 7,000 hertz. So LPF of 30 is 7,000. Exactly. I think we did that in the previous video. Whoops. And then a value of 70 for HPF is 7,000. Cool. So that's a bad example because it's an exact value. We want to find, you know, one where it has to actually figure out what's the closest, not which one is exactly it. Go on, mate. What are you doing? All right. So for 10,000 LPF, 23. Yep, that's pretty close. Only 33 off. And 77. There we go. Awesome. Looking good. Looking good. All right, so that is the mode 2 done, and that was the harder of the two modes. Now we got mode 1 to do. Now, if you haven't already attempted mode 1, I'd like to encourage you to pause the video and try and get that going. It's a lot simpler than mode 2. But if you don't want to pause the video, that's fine. We can just keep watching. All right, so this is going to involve prompting the user as well. Prompt the user for the value they want. Convert to number. Make sure the number is between 0 and 100, because those are the values that Wwise has to play with. You can't go above or below that. Cool. So let's start there. So Wwise search. What do we call this? Wwise value search. Type your Wwise filter value. Cool. So then convert to number. So Wwise value equals to number. Wwise value search. This time I'm not overriding it like I did in the other example. I'm making a new variable name for no reason in particular. Just another way to do it. All right, so now we need to check if. So what we could do is, like, the rest of the code could be wrapped in an if statement. So if Wwise. So what we're going to have to do is we're going to have to first make sure that Wwise value is not nil, because if this user input has non-numeric characters, when we do the toNumber function, Wwise value will be nil. And if we try and compare nil to a number, it's going to throw an error. So first we need to check that it is not nil. Checking that Wwise value is not nil, right? Now we can do our numeric checks. So checking if it's in that valid range. So it needs to be greater or equal to 0, or, and Wwise value is less than or equal to 100. And we've got an and for each of those. Now, we talked about the word and before, because we've got two condition statements here. And what the code is going to do is it's going to evaluate both of them. This will either be true or false, and then this will either be true or false. Now, how an and statement works is both of them have to be true for the whole thing to be true. Both conditions need to be true to proceed. Okay. So that's what the and keyword does. Two condition statements, both of them need to be true to proceed. So the value needs to be greater than or equal to 0, and it also needs to be less than or equal to 100. Otherwise, it's not going to work. Okay, cool. So now that we've ascertained that it's in the valid range, so LPF value is going to be whatever this value is when we look it up in this table. So if it's 66, that's what the user typed in. This is what we get out of it. That's the value. Where are we? So we look up our Wwise value in that table, and this will give us that right-hand side of the equal sign in that table. And likewise for the HPF value, oopsies, HPF value of Wwise table will give us the right-hand side of that, depending on what the user typed in. Cool. So if we're in here, we know for sure that we'll have these values. We don't need to do like little checks for that. But yeah, print this info to the console. So same sort of deal. We're going to construct a big old string using concatenations. The string is stored in a variable called message or MSG. Cool. So searching for Wwise filter value. And this is what they're looking for. Concatenated with, so the LPF value will be LPF value. So I'm running out of room here. I could keep going on the same line, but just for the purpose of the video, we can do this. You know, that's half of the string that we want, and now we're going to keep building to it down here. So we're concatenating this with whatever I'm about to type now. So that's cool. Space hertz. And then high pass filter value will be HPF value concatenated with space hertz. And then we want a couple of character returns. All right, I think I did that well. Let's see how we go. So this is type 1, and let's look at 55. Cool. So 812 low pass and high pass is 1922. I'm thinking that we could put in some character returns. Where? Maybe right there. So right there. And maybe another one right there. That might come out kind of neat. There we go. And maybe I'm being a little bit pedantic here, aren't I? That can be a colon. Whoopsies. Whoa, whoa, whoa. What you doing? Ah, it's behind the... Of course it is. Cool. I like that. Oh dear. What's it doing? Ah, I'm typing it in the wrong spot? Yes. Okay. Good. And now let's try 500 hertz. Yeah. There we go. And we could format this the same way as this, or other way around, sorry. So we'll... so this is mode 2 we're looking at. Looking for this. That'll be a colon, and then a line break. Wwise LPF is this, and then we've already got one there, so that's cool. Let's see how that goes now. 600. Sweet. There we go. I'm happy with that. This is a very useful tool. It really bugs me that Wwise just has these filter values. just 0 to 100. I don't get it, but this is one way that we can work with that. Cool. So if you're a Wwise user, hopefully you find that useful, and I will see you in the next one.